وأتوقع دكتور يحيى لازم نأخرها شوية عشان الصلاة عشان الناس.
أوكي مو مشكلة، ممكن دقيقتين 3. So we'll wait for 3 more minutes and then we'll start.
Okay.
اوكي هنبدا دكتور اكرم.
Okay.
Okay, بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Hello everyone and welcome to another webinar in this series on where we target students and also all the members of the community who are interested in learning about the programs that are offered here at KFUPM. Tonight we have with us a very special guest. We have with us Dr. Akram Ahmed. Dr. Akram is an assistant professor in the Department of Computer Engineering. He obtained his PhD degree from University of Maryland, Baltimore County in the US. Dr. Akram has research interest in artificial intelligence and wireless communication and Internet of Things, in particular in underwater application. Dr. Akram also has a 10-year industrial experience, and he's known for his role in the digital transformation of the curriculum at KFUPM. He was a member of the team who designed and managing the delivery of the 3 courses in the digital foundation, which are common to all KFUPM students. He will even become more popular next year when his course COE 292 Artificial Intelligence will be offered for the first time in KFUPM to all students. He's going to talk tonight about some very important questions related to the computer engineering discipline here in KFUPM and in general, and the relationship between computer engineering and the other disciplines within the College of Computer Science and Engineering and outside. And I know that you are waiting for answers, so I'm going now to turn it over to Dr. Akram. تفضل Dr. Akram.
Thank you, Dr. Yahya. So basically what I am going to be talking about today is what is computer engineering and what fields basically does it cover, and where can I be when I graduate once I study this field. So I'll start this with a very a short story that actually happened to me when I graduated. So I graduated, my bachelor's was in electrical engineering, and I graduated. So when I graduated, I went to my friend's place and he had his grandfather sitting there. And he went to his grandfather and he said that this is one of my friends who graduated with me. And his grandfather's response was, "Oh, mashallah, كهربائي زيك." But that was the first shock that I got in real life, that after 4 years of studying, the perception was that an electrical engineer is nothing but a كهربائي. And from there, we moved on. And so that was very interesting. And that is something I think that people do misinterpret the importance of the field and what it can do. And hence, this presentation is basically going to shed some light on what basically the computer engineers do. So if you are wondering about what is computer engineering, what will you learn basically in computer engineering, and after I learn this, where will I work? What will I be doing in the actual field? What am I going to do in my life? And the bigger question, why should I actually come to COE department? Why not the other departments? Then you are actually at the right place. We are going to be tackling this question, or all of these questions, and then we will talk about how this actually is in line, the computer engineering department and the degree that it actually provides is in line with Vision 2030. So this is basically an introduction of what we are going to be basically going in the coming few minutes. So what is computer engineering? Computer engineering is nothing but a field that actually was given birth by electrical engineering. So before the invention of the computer, the electrical engineers actually worked, and until they actually found the transistors, computer engineering was not on the spectrum actually. And then slowly, computer engineering came into place. And then there was the birth of computer science when computers actually started. And then we had to write programs and softwares to actually control these mechanical pieces or machines basically that were built. So it is basically an intersection, as you can see, between the electrical and computer science. So the electrical engineers basically are going towards more of a hardware design and are getting deep into that, whereas the computer science are more into the software. What computer engineers do is combine both of these techniques, and then they can actually perform the tasks that are in hand. So this is the uniqueness of computer engineering. So they are basically what we call integrators that basically can take a piece of hardware and a piece of software and tell you how to optimally use both of them and how you can get the maximum benefit out of it. So this is where electrical engineering, computer engineering, and computer science actually fall into the spectrum. So this should put a perspective. Now, what we basically say in computer engineering, we are going to teach you some of the electrical engineering and some of the computer science skills that other graduates of these two departments have. But what we are going to be focusing on is how you could actually integrate these two to develop a solution. Okay, so you have a hardware, you have a software. How can you actually work with both of them and then come up with some solution that will give you the best performance? This is basically where computer engineering have their basic skill presented. So given this into perspective, what we have done is we have made a program. Okay, so this is, if you go to the site of the computer engineering department, you will find this site, and this is basically the courses and their dependencies on each other. So what are these courses basically referring to? So not going too details on all the courses, basically these are the math courses or the science courses that you will be taking: chemistry, physics, math. So these are for the ABIT requirement and all the other things that every engineer should have in their arsenal, basically, to be working as computer engineers. In addition to the pure science, we have the digital foundation course that we have just introduced, so that everybody in KFUPM is basically digitally enabled, so that they can participate actually and perform well in the field when they go, and they can build our digital economy that we have in the Vision 2030. More on top of that, we have courses that are from computer science department. So we selected courses from the computer science department that is going to be key in identifying how you can actually integrate a software in with a hardware. So this is basically the basic idea behind it. So we actually go and take the computer science courses, and you actually learn how to program and take all the basics that the computer science actually has. We don't venture as much as the computer science people do, because you'll see that we have a large chunk that is not for computer science, but we do teach you the basic of programming and all the other techniques that you will require in the field. In addition to that, we have an electrical engineering. So we do have the course on electrical engineering. And of course, there's a lot of overlap between the electrical engineering and computer engineering. So some of the courses that are actually taught by computer engineering are basically they're sprouted from basically electrical engineering, but however, they were shifted later on to the computer engineering because they became too much of on demand, just like the digital design and all of those things that we'll talk about in few seconds in the next slides. So computer engineering courses, here are the list of computer engineering courses. So you can see we are balancing between computer science and electrical engineering and computer engineering courses so that you have the skill in all three fields. And then of course, we do have this course that's in the middle. Now this is a course that there is a lot of dispute whether it's an electrical engineering course or a computer engineering course. The electrical people like to call it an electrical course. The computer engineering people like to call it a computer course. So we basically are going to leave that to as a separate entity, so we don't go into that debate. But however, you can actually map it to electrical engineering or computer engineering, it doesn't matter. And then at the end, in the senior year, what you basically have is your concentrations, okay? So you have the concentration after you get the foundation. Now notice what we're doing. We're doing a foundation in science, we're doing a foundation in computer science, and we're doing a foundation in electrical engineering, and then we are giving you foundation in how to integrate the electrical and the computer, or in the computer science and the electrical engineering components together. Then we open the doors for you to select a concentration. Okay, in the concentration that you can select whatever fields that you want to go into, and we'll talk about these concentration in the coming few slides. Okay, so the typical question that are asked: what are computer engineers and what do they do? Okay, so yes, computer engineers are people who work with hardware. That's the first point over here. So you do have to deal with hardware. That's life. When you work with anything, you have a hardware. You have a mobile phone in your hand. That's a hardware. You have to deal with it, okay? You have to work also with something called the infrastructure, okay, or the IT product. So you have to have a network, just like your mobile phone is working. You have to have a GSM network that you connect to. So you have to understand all of these things, and you will be working with also those infrastructure. If you have a network, whether it was wireless, whether it's wired, or whatever type of infrastructure is there, this is something that computer engineers actually get involved heavily into. We do the software development. Actually, sometimes software development done by computer engineers are specifically targeted for embedded systems or microcontrollers, in which the computer engineer has to be a better programmer because he basically needs to understand how the hardware is working so that he can actually implement whatever we want in a very efficient manner, okay? So if you're targeting programming, computer engineers can do actually programming. However, they're very good and they excel when it comes that you have to work with certain type of hardware, and that is the reality of any programming that's going to happen. You will at the end have to work with a hardware that is going to be running your software. And if you have that knowledge, then that makes you unique and makes you a better producer of software in the market, okay? So if you want to work, for example, if you want to work on the application onto the mobile phones, if you want to work onto real-time applications or anything that requires, for example, Internet of Things, we're going to talk about the Internet of Things and how we have to actually have, each device will have a microcontroller might be in it, and then we'll write software programs that we're going to control those microcontrollers so that they can send the data. All of these things, then you need to have some information of the hardware and the software, and this is where the computer engineers exactly fit. So you can actually work with operating systems, and of course, what COE graduates are known for are they are the integrator between the software and hardware. Okay, so this is basically how the market is viewing the computer engineering currently. So let's talk about the fields or the specialization or the concentrations that you can actually work with when you graduate from the computer engineering department, okay? So the first and most obvious one is the digital design and processors, basically. So if you are somebody who likes to do a design and work in the digital arena, you want to design a processor, how it works, you want to work with the cache memory, how the interaction happens between the RAM and the processor, what happens inside the processor, how can I make processor faster? These are basically things that this field is basically, you have to come to computer engineering department because you will not find this in any other field. So this is one of the most important fields that computer engineering cover, which is the digital design. However, this is not the only field, this is just one. Now, as I told you, you basically learn computer science and electrical engineering. Over here, if you're going to digital, we gear you to go towards the electrical engineering more than the computer science, but we do keep the knowledge of computer science so you can actually write programs and build a hardware that can actually be utilized by computer scientists to write software that can actually provide service in the best manner possible, okay? So this is one field. Let's go to the other field. The other field that people don't know of is cybersecurity. Now, cybersecurity, there is cryptography, there's data privacy, there is cloud security, there's blockchain, there are digital forensic, and you keep on security. You have seen what happened in Aramco a few years ago when they got attacked, their entire system went down. Now, over there, why are computer engineers are better fit into the cybersecurity? Because again, as a computer engineer, as you've seen, we have given you skills in electrical engineering and in computer science. So you do have knowledge of the hardware and you do have knowledge of the software. So you are the best person to actually do the security because you can actually cover both fields, okay? So you can actually, and you have also the basic science information that every engineer has. So it actually completes everything together, and you then become the best candidate to basically be targeting the cybersecurity, okay? So security is a very big field. You might become specialized in computer science and security. You might be specialized in electrical engineering and security. But if you're looking at a level where you, as a new graduate, you do not know where to go. So coming to computer engineering will open all the doors for you. Whereas if you go to electrical engineering, you'll be locked to the hardware. If you go to computer science, you'll be locked to software, whereas computer engineering will open more fields for you. That's the power that computer engineers can actually possess when they graduate. Moreover, one of the classical things that we actually work with is networks and mobile computing. Okay, so networks basically is one of the fields where you have to integrate many computers together. So integration is basically one of the powers of computer engineers, okay? So when you have to work with hardware over here, you might have routers, you might have wireless Wi-Fi things, Wi-Fi networks that you want to connect all together. You want to have a fault tolerance system. You might have remember like a few days ago, we had Tawakkalna, for example. They actually had a failure in their system where nobody could actually log in. And that is basically maybe one of the reasons could be that they did not think of a fault tolerant system. And this is one of the things that if you come to the computer engineering department and you basically want to specialize in networks, we will teach you in basics of fault tolerant network. And then in the MX courses, you can build on this and go on further. You can work with cloud computing nowadays. STC and Aramco, for example, are looking for hosting cloud services locally. So if they do host locally the cloud services, companies over here will have to shift their infrastructure so that they decide which part of their network they want to export to the cloud and which part of the network they want to retain due to some security or some regulations that prohibits them from sending information on the cloud, for example. So all of these are fields that you can actually work with, and there is a lot of innovation in them and a lot of perspective or a lot of opportunity actually in the market in them. One other thing is the computer systems for high-performing computing. Okay, so high-performing computers are special computers, just like supercomputers, that actually are designed to perform a certain task. If you remember, in the time of the 1990s, I used to watch a movie called Terminator, and what amazed me at that time that they had to use a supercomputer to do the graphics for that time. So for that time, or for that era of time, basically they had to go to a specialized computer to basically do all the graphics that they wanted to do. And that was basically a high performance computing field at that time. Okay, so it's even touching us nowadays. Now computers are becoming faster and more powerful, and there are more powerful softwares and hardwares that can actually run. However, until now, GPUs, for example, parallel processing and multi-threading is one of the key things that this high performance computing field actually tackles. And if you're interested in such things, like you're a person who likes to play lots of games and you want to know the cards that are made, the graphic cards, and how do they work and what are specialty about them, what's different in the GPUs that are in them, then this is the field that you can actually work with, okay? So this is basically an overview of the computer high performance computing. One of the other fields that we are very, very involved in is the robotics field. Okay, so the robotics is one of the fields that basically when you have an arm, for example, a mechanical arm is trying to pick up something and it's trying to do its work. There are lots of motors. Yes, there is mechanical in it, but there is electrical in it also because there's some electricity, but there are some people who are controlling the motors of the arms, and when should the motor stop, when should it go. The movement is controlled by a software that is written on top of a hardware. It's an embedded software that is written. So computer engineers here fit exactly, and they can actually participate a lot. Like most of the work is done in control softwares, and control softwares, computer engineers fall into the right category on writing such software. In addition to that, you might have heard of computer vision for self-driving cars. A self-driving car, for example, will have a camera or will have different sensors. One of them will be cameras, and in cameras we'll take pictures and then we'll identify objects. We'll identify this is a car, this is a human, and then we'll have to avoid these objects. We'll have to put safety protocols in. So all of these coming into action, and computer engineers, again, now there's a sensor over here. So we teach you how to work with hardware, which is a sensor, for example, a camera, or maybe something that is sensing voice or whatever, an infrared type of sensor, and then how to take the data and how to control the vehicle so that you are capable of steering away from danger and safely bringing people back home from the office, for example. So this is one of the other fields that computer engineer opens for you, and you can actually participate in this in a very easy manner because you actually have got the skills that electrical engineers have to know the hardware and the sensors, and you have the skills of the computer science and programming. And now what you have to do is you have to combine and integrate these two skills into a product, and that would be basically, for example, a self-driving car or a robotic arm. Okay, embedded system is another field where you can actually participate, and this is one of the highest fields that are going up due to the Internet of Things. Embedded system are basically microcontrollers, small microcontrollers that you put into the machines so that you can actually control their behavior. Nowadays, even a coffee machine, a washing machine, okay? In fact, I have seen hair dryers that have chips in them. So it's just a hair dryer that's basically drying your hair, but it's basically controlling the flow of air and the temperature so that your hair doesn't get damaged. Okay, so even the smallest type, a toothbrush, is getting an embedded system in it. So embedded system programming in the world is going as a very high market, and there are lots of things that embedded system have to take care of. They have to be task specific, they have to be highly reliable, very low power and low cost. Now you have to think of a hardware and software that will achieve this. And this is one of the main skills that, and one of the main fields that computer engineer actually deals with. One of the most interesting part that the future is looking for is the Internet of Things. And this is where I also specialize in a bit. So I'm just going to be more lenient to this type of specialization. So Internet of Things is basically what? They're saying everything on the world will be having a chip in it. And then we will connect all of these chips together so that they can communicate and they can deliver a service for us, okay? So for example, we can have connected health. So we can, just like Tawakkalna basically is a connected health type of thing that is detecting if the virus is basically spreading. And if it's in one location, we can actually track those people. So it's basically, now you can see the Internet of Things, how is the different devices basically are connected together, and we can actually monitor a pandemic, okay? You might have smart homes. So we're talking about smart homes. When you wake up from your bed should tell your coffee machine basically that, hey, this person is waking up, he has left the bed, please make the coffee for him, so that by the time he goes, brushes his teeth, and he comes back downstairs, he finds hot coffee ready for him, fresh made hot coffee, okay? All of these things, just like putting in smart homes and all the new things, the door should open for you. Whenever you wake up, you're lying on bed and you wake up and you're going to the bathroom, the bed will tell the bathroom, hey, please turn on the lights, because I know as soon as he wakes up, he goes to the bathroom and he's going to be going, washing his teeth, whatever he's doing. So all of these are applications that are there in Internet of Things. You have smart retail, smart cities, smart supply chains, wearables. So you might have your watches that you wear, for example, the Apple Watch, and the Samsung Watch. They actually can communicate and they can send data, the health data. If you are sick, you're having a heart attack, that watch can actually detect it, and then it can actually trigger an alarm in the system that will go, and an immediate paramedic will be discharged to come to your location and give you medical attention, for example. All of these are examples of Internet of Things and how this is actually going to be forming our future world. Okay, so when you come to computer engineering, this is one of the basic fields that you can come. Dr. Loy, myself, we are basically leading the Internet of Things, and that's one of the prominent fields in the future that we think will be there. One of the other subfield, and this is actually, I think this is the most exciting one, is the quantum computing, okay? So the quantum computing field is there. Quantum computers are computers that are capable of doing computation that are not that cannot be done on legacy computers, and they can do it in a much faster way, in a simpler manner. So quantum computing is coming into action, and basically what they're talking about is they can actually work on cryptography, they can work on algorithms, they can work on any problem that is for search, and also now they are introducing machine learning for quantum computing so that they can actually have quantum computers that can learn and they can perform many tasks. So quantum computing, since you have the ability as a computer engineer to understand the hardware and software, you are one of the best fits, basically. You are the exact fit to be coming into the quantum computing field and learning things from it, and then innovating in the future new solutions that can come out with. So if you're looking for some sort of research or some sort of work that requires a lot of computation, and you would like to basically break the codes that are there right now that legacy systems cannot break, then quantum computing is the field for you to go. Okay, so we've talked a lot about the fields. Now let's talk about what does computer engineering has to offer. So as a computer engineer, we have two programs that we have updated. We had the computer network program. So we have a new updated program in which we teach you about computer networks and the emerging technologies, just like cloud computing, fault-tolerant systems, and all the new technology. We also have updated our embedded system, so you can get a concentration on the embedded system. Okay, as I told you, we are basically having the background of electrical engineering and computer science. So you could actually participate in the artificial intelligence, okay? So you can select your concentration in the artificial intelligence. You can select a concentration on Internet of Things. You can also go to robotics, quantum computing, and cybersecurity, okay? So once you enter the computer engineering field, once you come to graduation and you want to have a choice, you have 7 choices, and we are working on more, by the way, okay? So we couldn't put all of the choices right now on the table due to the lack of faculty members working on them, to be honest. But we are going to be adding more and more, and you will see. And all of these are basically, why are we offering these type of concentrations? Because these concentrations we see are aligned with the Vision 2030. And this is where this country, or where Saudi Arabia is basically going, and it's going to target these markets, and we want to make the workforce ready for those, okay? So we are offering these concentration in that in these fields so that you can graduate. And once you graduate in the Vision 2030, you have all the government sectors, all the private sector is targeting these things, and you will be there as a unique pick for them so that they can pick you and then you can continue on. So it will be a win-win situation for the market, for the university, and for yourself. So what is the job market? That is one of the most asked questions that I do get when people come to me and talk to me. So I'm just going to give you a brief overview of the job market. So we do think that the job market of computer engineers is increasing, and it's increasing rapidly. A very conservative statistics that I have recently seen, it says it's about 5% increase in computer engineering job offerings, whereas the other fields, just like electrical, it's basically coming to be a 2.5 to 3%. So there is a high increase in the demand of computer engineers, okay? And you can justify that because look at the IoT, for example, they want embedded systems. Now they are looking for computer engineers to build those things. Look at the security. Security people do not want somebody who's just in software or who's just in hardware. Basically, you're talking about data privacy. You're talking about data integrity. You're talking about a whole system. So computer engineers do play a lot of role in that. And we've seen that in the job fair last year, there was an increase on the demand of computer engineers. So that's one thing that we'd like to share and tell you that, hey, there is a job perspective. Now, leave my words aside. Let's look at the sectors that we have, okay? And how do we envision that the different concentrations that we have in computer engineers will fit in them? So over here, I'm actually giving you a lot of these are concentration. For example, you have the IT concentration over here. The IT concentrations has computer networks, enterprise systems, integration, application, and development. All of this, a computer engineer can actually basically work in, okay? Then you have the infrastructure where with basically what we're talking about over here is networking and cloud computing. These are basically are targeted towards the infrastructure sector in the market. So if you are working in this, you graduate, you can actually work on the cloud computing initiative that maybe Aramco has or STC have, or you can go to other companies and then work with them to actually interface to such services that will be provided in the future. So you have service and entrepreneurship type of things. Now, entrepreneurship is in Vision 2030, and we do provide you ability to go to Internet of Things, the artificial intelligence. In these things, you can actually become an entrepreneur, and you can build systems that that you can market for, and then you can become a company on your own. Basically, we have an entrepreneurship institute over here in KFUPM that will help you to do that. And taking these basics and with the capability of working with hardware and software, you will be more capable of doing it. So you'll be basically working with system design, product management, and project management, all the nice things that come with entrepreneurship that you have to tackle. The defense industry, okay, it's in Vision 2030 that we want to become better and better in defense. Embedded system, for example, is one of the key elements that you can actually work with in defense systems. They do require this a lot. I've been in this market. Digital system is over there. They want to design some specific things that sometimes have some restrictions or for trading. Countries come and say, this is our secret, we'll not give you this. Then at those time, you will basically be looking for digital system design and processor design and all the other stuff. Of course, you'll be talking about the operating system and the firmware. So these are 4 sectors, and you can see that different sectors, we are showing you the different capabilities that you can earn in the computer engineering department. And after you earn those, you can actually fit into these and then produce some support services, or you can actually work directly to the companies. Again, there is the security, the crime investigation, and IR4, basically industry R4. These are all other sectors that you can actually contribute in, okay? For example, in the security, you have the cybersecurity, you have the data privacy, you have applications, systems, and infrastructure that you can actually work with. And there are lots of companies that basically want these type of things to be done. There's also the crime investigation. I was sitting with some people and they were talking about that there was somebody who actually photographed himself taking a car and doing some acrobats with it in the middle of public. And the police, after a few days, when this video became viral, got to the video, and then they started an investigation, and they narrowed down the person, and they caught the person, and he's serving his time now. So basically, this is crime investigation, digital forensics. If somebody attacks your system, you want to know how he attacked it, who attacked it, what did he do, all of these things. So these are very important fields. Just like when Aramco was down, the crime investigators actually came and looked at the system. They looked at where the attacks came from, how did they do it, all of these things. So it's just like a private investigator and the police that used to go and solve all these mystery cases. You become now in the digital era, you become an investigator and you investigate what's happening in the digital environment. Industry 4, this is the industrial trend. So it actually has all the other, all the robotics, the smart cities, the digitization, artificial intelligence, all the other things. Industry 4.0 is basically targeted towards that, and you are a well fit for this type of industry, okay? So we have shown you different industries and different fields that you can work in. Now, after this, don't take my words on it, okay? I'm just a person who might have a biased view because I am from the computer engineering department. So let's talk about this is a meeting that has happened, آفاق التقنيات المستقبلية للمملكة العربية السعودية. It was hosted by CAXT, and it was basically with the Vision 2030. And they have identified these areas. And these areas basically are in the aerospace, the environment, the energy, the health, the surface, and the digital sector. And they have identified that these are the areas where the Kingdom of Saudi Arabia should go forward, and this is what's being targeted currently by all sectors, okay, whether they're private or public. This is to drive a vibrant economy for Saudi Arabia. This is what they are planning to do. So we are not in the aerospace, we are in the digital part, so التقنيات الرقمية, because we are in the computer engineering department. We are the basis of those. So let's talk about what they have listed in it. So if you go, and I can show you the report if you like, I can share it with you. It's a free thing that you can actually get on the web. So they listed that this in the digital components, this is their list in the order that they have presented it. I will show it to you in the next few slides, but they have listed it as hardware architecture to be the number one. Okay, so this is the number one technology that they should target, hardware architecture. That's where you design processors, digital design comes into place. The second thing that they want to target is the networking. Okay, networking again is a computer engineering thing, and you can see in the digital component, computer engineer is coming on the top of the chain. Okay, it's not on the bottom of the chain, it's actually on the top of the chain. The hardware architecture networking is core computer engineering. Human computer interaction, now this is where robotics come into place. Then you have machine intelligence. Sorry, I have a spelling mistake over here. It's intelligence, actually. It's machine intelligence. I forgot the T. So machine intelligence is something that they are targeting. So you can actually come into the computer engineering department, go and take the concentration in artificial intelligence, and you will be ready for that market also, okay? So security, privacy, and abuse prevention. So basically that's, again, in security. One of the things I was talking to some of the group of people in security, and they were talking that nowadays they are basically targeting security, and they put the processor under an infrared, and they look at the heat signature, and from the heat signature of the processor, they determine what is the operation that's being done in the processor, and then based on it, they actually break the code or the encryption that you're doing. This is something done in the military. For example, they do it so that they can actually get the information out. So this is basically, now you have a hardware and there is a software. Then 6 is communication. And you remember the course that I told you that we have a dispute, whether it's computer engineering or electrical engineering. Communication basically is that course. So we do say that communication is basically partially electrical, partially computer. Then Internet of Things, and finally quantum computing. Okay, so in this order they have listed the digital components. Okay, so as you can see, the fields that are offered in the computer engineering department are exactly aligned to this. Okay, now we didn't know this when we started planning, okay, but we had the Vision 2030 in front of us, and hence we came up with the concentration. It looks like that everybody is looking at it as we are looking at it in over here in KFUPM. So basically our new concentrations, especially in the computer science and engineering, the College of Computer Science and Engineering basically are targeted towards these technologies, okay? So this is just screenshots from the, from this meeting. They actually are talking about the hardware architecture, and in the hardware architecture, basically, this is what they're talking about. You can go on these on your own time later on if you like, and if you have an interest in some, I am there to actually answer any questions. So they are also talking about networking, and this is the networking, all the networking fields like cloud computing, fog networks, talking about software-defined networks. All the mobile applications are coming into networks. Notice it's not something in programming, it's in networking now. Working with computers, okay, human-computer interaction, basically, تفاعل إنساني. It's talking about virtual reality and all of the other things. So these are the things that they are talking about in this conference that was done by Malik Abdelaziz by CAXT. And this is how the Vision 2030 is basically done. It's basically implemented in Saudi Arabia. It's not done, it's implemented in Saudi Arabia. There's also the machine intelligence, this the security, and the communication, and these are the subfields that are in it. So as you can see, the computer engineering department can satisfy most of the digital vision that this Malik Abdelaziz or CAX was actually looking for. So we are aligned with the market so that when you get out from here, you can actually go and participate directly. Okay, so this is basically And the last is the Internet of Things and the quantum computing. So I'll let you go cruise through these things. So they're talking about like edge computing, the Internet of Body, the blockchain, all of these things, how you can actually use blockchain and Internet of Things. And all of these technologies are being targeted, and the higher administration in Saudi Arabia are basically being briefed on these. And this is the idea where they want to go to in the coming few years. Okay, so with this, I come to the summary of my presentation. So basically, computer engineering is a very interesting discipline. Okay, it has science, technology, design, software, hardware. We have a widespread, okay, a very widespread. Computer engineers work in many industries. Okay, so you can actually work, as I told you, if you go to the different fields, you can actually participate in like at least 8 sectors, okay, in the industry. Not talking about the government sector, which is a different sector by its own. We did not talk about the government sector, but you do have, for example, Sadaya will be very interested if you take the artificial intelligence. The Markaz al-Ma'lumat is very interested in the graduates of computer engineers because they are basically having the information of security, for example, if you specialize in the security field. There are many things that you can actually do. We teach you high tech, and the new curriculum that we have designed has the up-to-date knowledge so that once you get out of this university, you are at the edge of the technology that is right there now, okay? So that's why we built it that way, and we have complemented that. So we know that in the bachelor's it's too tough to get you to that. We then added the MX courses on top of it so that you can actually come in and then take the MX courses and become someone who is ready to participate in a company from day one. In the previous history, I worked in a company, and I used to employ people from academia, and I used to train them for at least 1.5 years before they can actually produce. And now, when I see these programs, I can see a shortening of that time. Of course, it will not become 0 because you need to learn the culture of the company before you can actually do it. But the culture of the company you can learn in few months and then start participating. So we have bridged the gap for the graduates and how they graduate and then go after their graduation and work into companies. So with this, I will end my presentation. If there are any questions or comments, please let me know.
Thank you, Dr. Akram, for this very informative talk. We now open the floor for questions and comment from the audience. Please raise your hand if you want to ask a question through the mic. Otherwise, you can type your question into the chat box. We have a question here from Mr. Ali Al-Akhras. He's asking about, what do you mean by hardware architecture?
So hardware architecture, basically, if we go back, it's designing the digital design, the processor design. It's basically coming in the first field that we talked about. So that's the hardware architecture in the level of basically designing components. So for example, there might be a component that the military wants that they cannot obtain from outside because it has some restrictions on it, something like the ITAR restriction, the international trafficking restriction, or some secrecy that they don't want to do. At that time, you will be basically talking about the hardware design, and you want to design those things, okay? So you might be working on FPGAs, you might be working on mixed signals or these type of things in the level of a hardware. So the hardware architecture sometimes can be also taken as a networking. So you have maybe data centers that are regarded as nodes, and those nodes basically are integrating together, and then you have to make an architecture on top of it. So the architecture is a very open word when you say it. When you say hardware architecture, basically what we mean as in academia or even in the industry, when we say hardware architecture, is how you build one component on its own.
Okay, I have a follow-up question here. Since you have an industrial experience with this, some students, they think that This is related to design and manufacturing of processors, and this is something we don't do in Saudi Arabia. So can you give us an idea about the hardware thing, the type of work that is related to hardware that we do here in Saudi Arabia?
Okay, I'll give you an example that I went through personally. So I actually, when I graduated, I went to work and I got a job in a company, and they gave me a piece of board, and they said, yeah, you're an electrical engineer. Please go ahead, debug this board. It's not working. This is the output that it should get. And we want that output to come out, because if you put in the system, this board doesn't work. I spent like 3.5 weeks until I found the problem. Okay. Now, when I found the problem, my manager was very happy, and he actually went to the vice president, who actually took that piece back to the customer, and the customer was very happy. Now, over here, I had to go to the architecture details. I had to look. There were, for example, there were processors in it. I need to know what the processor is. What is it doing? I actually tapped onto the bus, and I caught the data that's going to the processor. I analyzed that data. I looked at what's going on. What is the functionality of this? Okay, it's not basically designing. We don't have designing. I agree with you. There is very few designing capability. However, when it comes to repair, for example, in the military, when you have assets that are very expensive and you cannot actually spare to buy lots of them, and you have to work with them, then basically this design capability is there. I do agree that the market is not as wide, for example, for software development, but there is a market. And the thing about this market is that this market is more highly paid, okay? If you go around the world, hardware designers are more, or people who know hardware are higher paid than people who work on software. That's a given fact. However, the opportunities are still less, yes. Software market is a very big market. The hardware market is comparatively small.
Okay, another follow-up question, and we'll move to another topic, is a comment here on the chat that what about the developing or implementing algorithm in specialized hardware like FPGAs and running algorithms on GPUs, especially deep learning algorithms?
Yes, all of these fall into the, you will have to know the design, and basically it's coming into digital design. So you have to work with FPGAs. All of these things have to go into, you have to have knowledge of the hardware. That's what I'm saying. And then you have to have knowledge of the software also, because you want to design a program that is basically working on this, okay? So what is the size of the market? That is something that is very hard to predict. But there is a market for these things. I have personally had 2 people working on an FPGA for 2.5 years in a project. Okay, so and I used to go and visit them and see how the project is going, because that was one part of a targeting system that we were developing, or co-developing with a foreign company, and that FPGA was our part. So there was an opportunity where you can actually go and actually work on these type of hardware, and there is a demand for it. However, I again say it's not as high as a demand for a software development. So you
okay. We have 2 questions from Ghaida. She's asking about the HPC job opportunities in Saudi Arabia. Now, I have to mention something. Maybe you agree with me, Dr. Akram, that although we're talking about a niche market here in Saudi Arabia, but there is still like a good demand for computer engineers, especially in projects related to military, and because most of the defense projects, they involve hardware to a great extent. Now, speaking of this niche market, the question that is related to HPC job opportunities in Saudi Arabia, what do you think about it?
So for the HPC, the high performance computing, once we have the cloud computing coming in, like example, the Aramco HPC, the cloud computing is, then later on, all of these are gonna be coming. There will be derivative of those because we'll have now large set processors that are in one place, and then you can actually work in high performance computing. I do think that there is a market for them. For example, I'll give you an example. A nuclear explosion cannot be simulated by normal computers. Okay, the time delay for normal computers basically is impossible for that to simulate. So for those type of applications, you're talking about specific applications. For those type of applications, if you are targeting that market, then HPC is your way to go. Now, the thing that I would like to add over here, if HPC is something that you like, if you come to the computer engineering department, we will not just teach you HPC. Okay, we'll teach you other things so that even if when you graduate, you like that thing and you could not find an opportunity in it, you still have in your arsenal the capability to go in other fields. So you can go in networking, you can go in IoT, for example. You might be having a bit of a difficulty in going into artificial intelligence if you did not take those courses, but you have the background, so you can actually go outside the university later on, take some courses, brush up your capabilities, and then you will be ready to do it and even take artificial intelligence, for example. So it's basically at this level, when I'm talking about the bachelor's, I don't see that you fix yourself to one concentration and go. That will be my advice for the students. You basically have to know when you graduate, what type of capabilities, what is the range of spectrum that you have, so that if the market changes, so we're saying now IoT is very hot. Maybe by the time I graduate, so after 5 years or 7 years, maybe after 10 years, IoT will cool down. Okay, so this is the life. Okay, so 10 years ago, whatever was hot is not hot now. Okay, IoT was not there. No, IoT came and took place. Artificial intelligence was not there. Okay, so what you want is to have the capability to shift from one market to another so that you can actually maneuver between them and go. So that,
okay. This is why we are going to offer this specialized MX program on HPC and distributed systems. I think, Dr. Akram, you have heard about the announcement that was made by the STC. They're going to open 3 new data centers in Riyadh, Jeddah, and Medina, and Aramco is planning to open a new one in Sharqiya. Now, these let's say mega projects in the infrastructure, they need a lot of computer engineering students to run these projects after they are built. Do you agree with me?
Yes, yes. Not only computer engineering students, they also require a lot of capability from the people who are working in them. So the engineer in it will be in a lot of stress. He will be basically taking 2 or 3 tasks at the same time. So if you are going to be an electrical engineering and going over there, then handling software components will become difficulty for you and he will lose an edge. Even if you compete with them, you will have an edge as a computer engineer over the others.
Yeah, okay. We have another question from Ghaida. She's saying, does studying cybersecurity benefit you in IoT? What's the overlap between cybersecurity and IoT? It seems that people are still like undecided. They want to do cybersecurity and also they want to study IoT. So what's your opinion on this?
Well, so security is embedded in everything. So IoT also, there is security in IoT, for example. So if you are interested in both of them, you could go to the IoT and target the security field in IoT. Okay. However, in the level of bachelor's, it will be too tough. But in the level of master's, yes, you can actually have go talk to your advisor or the faculty who is working on the projects, and you can then tailor your projects, for example, to security of IoT. So you get benefit of the both worlds if you are interested into having security and IoT. So things are not clear cut. So if you are security, you cannot work on an IoT. If you're an IoT, you cannot work on a security. You can actually merge 2 fields. And this is basically where the market, in my opinion, is heading. And let's go in the 90s, the market was heading that you have to be specialized in one field. And if you are specialized in one field, you are the best person. Now the market's saturated with specialized people. Now the market is looking for people who are specialized in 2 fields. And that's why IoT is working. Artificial intelligence, for example, is working, okay? Because they're basically a mix of two disciplines merging together. So that's where it is. And if you are in security and IoT, you are in luck, because there is a lot of work on security in IoT going. So you could actually get the best of the both worlds.
There is a comment on the chat from the chairman, Dr. Ayman Al-Melhi, saying that we do have a course on IoT in the MX program on IoT. So basically, when we designed the program, we tried very hard to cater for people like Ghaida, so that they don't miss out like the other the good things in the cybersecurity program. Okay, we have about like 5 minutes more, so please raise your hand if you have a questions or type it into the chat. Otherwise, I will ask my questions. Since you have been involved heavily in the transformation that took place in the curriculum last year, we received some questions from students that things like, okay, now we have these concentrations that, let's say, on AI, and AI used to distinguish computer science and engineering students from other students on campus. Now it's open for everybody. So don't you think that our students, computer engineering, computer science, they will lose this edge because we are opening up the concentration for the other student?
I would disagree that they will lose edge. I think it will make them better, because now they have competition, okay? That's one thing. So that's going to be a positive thing. But again, when you look at the market, the trend of the market is not to have, especially the Saudi market, is not to have a person who's specialized in one field. It's to look at a person who can actually manage two fields and grow them both together, okay? So this is where the market is heading. There is the research maybe going on a different arena, but the market that we are in, no, they basically want people who can take two things and merge them together, okay? If they can employ one person to do two jobs, that's a win-win situation for everybody. So this is basically why even the academic people, they realize this. They realize that, hey, having a concentration basically just in computer science will not work. That is why the new trend in the university is multidisciplinary. We want to have multidisciplinary teams. We want to work with people who are from other fields. We want to do research in this so that these ideas can connect together, because this is where the world is heading towards connecting and working together.
So do you encourage our student, computer science engineering and software engineering, to take concentration from other departments other than the one in the college? I mean, other than computer science, and like
for example,
from math, electrical engineering,
from quantum computing, it is offered by physics, and I do think that they can actually do a lot of participation in it, and they can really excel in such type of such field, and there's a lot of perspective in it. I've heard that there's a lot of meetings that are happening with the faculty who actually taught the quantum computing. Dr. Flimban, maybe he's with us, and people have approached him and they are talking to him and how they can actually implement this into some government sectors and utilize the graduates and his expertise in these fields. So I do think it's going to be a lot of interest to take other concentrations also. However, when you take a concentration, please make sure, this is my humble opinion, that you do have a market for it when you get out, basically something that is aligned with the vision of Saudi Arabia or something, so that you do participate into a vibrant market.
When you redesigned the curriculum for the CO department, I think you did something very smart here. You have decided to have the course on computer and network security as a core course. So every CO student now, he has to take that course. Also the course on the design and modeling of digital system, the one on FPGAs.
Yes.
So that, I think it's very smart. Do you want to comment on this move from your side?
Yeah, so from my side, when we looked at all the digital foundation courses, then we decided Okay, so what should the computer engineer basically, as a department, actually I'm talking, what should a computer engineer have capabilities so that it will boost him when he graduates and it will make him shine and become unique from others? And those courses then were identified, just like the security course and the FPGA course, the digital design course, and those were pulled back into the course so that all computer engineering students will take those, and then they will have with them the skill to actually participate in a much vibrant way when they graduate.
So I think the courses, when I look at the degree plan, although it's a biased opinion since I'm from the computer engineering department, but I still believe that the new program still gives an edge to our students in the market. There are skills that only computer engineering students will have, the one like embedded system, digital system design,
Yes.
and computer networks. Okay, so the course on artificial intelligence, COE 292, which is will be offered to all KFUPM student. Can you tell us what went in the background? What's the story behind the decision to have this course in the computer engineering department? Is it like a wish from your side, or so? What went when you discuss where should we place this course? What happened?
Yeah, so basically when we started, there was an initiative to look at the Vision 2030. And then we looked at the Vision 2030 and what fields does it basically target. So we identified in it few fields that can be actually targeted by the department. And artificial intelligence is one of the basic fields that, that had very high chances of being successful within our college. So, but the problem happened with the artificial intelligence that most of the students do not have the background to learn the basics or the artificial intelligence techniques. And hence we came up with the digital foundation courses, in which we said we'll go to a programming course, the ICS 104, then the ISE 291, where you will get the data science background that you require for artificial intelligence. And then finally comes the artificial intelligence to give the students the background. Now, as I say this, the artificial intelligence course of 292, COE 292, is not very technical or is not going deep into the artificial intelligence. It's just giving a flavor of artificial intelligence and an introduction for non-computing background students. We also interesting for computing background students, but this is basically the idea behind it. So Vision 2030 is basically what is pushing towards this digital foundation courses, and the college has adopted this based on the expertise that it has and the future market that it actually has seen. We have done some industrial surveys, and we also have done some surveys with the students on which fields would they like to go to. And from all perspectives, AI came to be the number one. Artificial intelligence then was selected to be part of the course.
I would like to close by the following question, because it's very dear and close to my heart, which is business and entrepreneurship. And it's one of the main objectives of Vision 2030 is to diversify the economy. So you decided to have, in addition to the other 3 courses in the Digital Foundation, you decided to have a course on business and entrepreneurship that will be offered to all KFUPM students. I know that maybe you are not the right people to comment on this course, but can you tell us anything you know about this course?
Yeah, so I worked 10 years in the industry, and after 3 years, when I started working, I realized that I was very bad in business and I was very bad in finance, to be exact, okay? When the Digital Foundation courses were there and the idea came up that there should be a business course, I was among the first people who said, yes, there should be a business course, because the students that we have do not have any background. Like just for a simple example, if I just give you a sheet, expense sheet of a company, I had to wait, I had to study this for like 2.5 months. Then I realized, oh, this is nothing, but they're adding the numbers together, because the table looks so scary that I always put it away. So the students need to have some business background, okay? You are basically going, if you want to become an entrepreneur, you need to know the business. If you're going in any company, at the end of the time, you will basically be dealing with some management or with some financial issue of the company. And these things, the business part will come out in front of you. And most of the graduates did not have this background. So in this course, basically what I think what the business school have done, I've only read the description of the course and I was like very happy when I read it. This is exactly what I want an engineer to know when he graduates from his school. The later things we can actually teach him in the company, but if I was a company owner, I would like somebody with this background coming. So this is an edge that KFUPM is giving to its students that other universities are not giving. So this will give an edge for the graduate of KFUPM over the others, and hopefully it will help drive the market to the right place.
Well, I think the new generation of KFUPM students are very lucky. Sometimes I tell myself that I wish I can go back and study these things. But I think we are going to learn with them because we are going to teach them some of these courses. So we will learn as we go. So Dr. Akram, I will give you the last word if you want to say something before we finish.
So what I would like to say to all the audience over here that you are coming to a very bright future. Vision 2030 is there. Saudi Arabia is moving heavily towards it. And you are in a very exciting era where the KFUPM and the College of Computer Science and Engineering is basically pushing you towards that. You can actually take advantage of this and become successful and help drive the economy of the company and the future of this company, of this country, basically, in the coming few years, if you take the right initiatives right now.
Thank you, Dr. Akram. Well said. And thank you to everyone in the audience. And as I have mentioned on the chat, the lecture is recorded and I have already posted the link on the chat. I'm going to post it again now also. I have also posted the contact information for Dr. Akram. You can reach him via email, and also his office phone number. This is the link. I have just posted the link for the recorded lecture. Thank you, Dr. Akram, again. And we're going to see you again next week in another webinar in this series on computer engineering and its the opportunities in this field. Thank you, Dr. Akram.
Thank you.
Assalamu alaikum.
Salam.